Okay, the last name nomenclature that we need to work on is acids, naming acids. So in this class, we're going to define acids as those compounds that start with hydrogen in their chemical formulas. So if you see a chemical formula that starts with hydrogen, we're going to be placing it at the beginning of the compound formula, then it is an acid. Sometimes if you're talking about an organic acid, you'll see it placed at the end, and you'll see it with a COOH because that's a carboxylic acid. However, for this class, we will talk about acids as things that start with a hydrogen. So anytime you see something that starts with a hydrogen, they are acids. So the naming rules, we have 3 of them for acids. Okay. For the acids, we're going to always have to consider the anion in terms of the naming. Why is that? Because the cation is always going to be hydrogen. So if it's an acid, the hydrogen is going to indicate it's an acid. So the name is going to come from the anion. So if your anion ends in IDE, so that's typically going to be something directly off the periodic table. Your anion would be something like nitride, oxide, something like that off the periodic table. However, there are a few polyatomics that end in IDE that you need to be aware of. So if your anion ends in IDE, the way we're going to name it is we're going to first write the word hydro. Then we're going to take the root of the anion and change the suffix to ic, IC. So for instance, if you see something that says HCN, it starts with a hydrogen, so that right there is an indication that it is an acid. Okay, so then you're going to go look to see what CN is. This is a polyatomic. It's 2 elements, right? It's a polyatomic. When you go to your polyatomic list, you see that CN is cyanide. It ends in IDE. So right now we're going to write the word hydro. Then we're going to remove the ide from here and replace it with ic. So instead of being cyanide, it's cyanic. And then you add the word acid. So the acid would be named hydrocyanic acid. So this is for anions that end in IDE. You're going to add a hydro at the beginning, and you're going to replace the ide with ic at the end. Hydrocyanic acid. If the anion ends in ITE, that right there is an indication it is a polyatomic. Remember, your polyatomics ends in ite and ate. So if you have an anion that ends in ITE, you're going to take the root of the anion and you're going to change the suffix of the anion to us. So for instance, if you see HNO2, that H, that's an acid. So let's look at the anion. The anion is NO2. You look that up on your polyatomic list, and you find that NO2 is nitrite, and then ITE. You're going to remove the ITE and replace it with us. So now you have nitrous, and then you add the word acid, nitrous acid. If your anion ends in ATE, again, that's an indication that this is a polyatomic. So you're going to have your polyatomic list handy. You're going to use the root of the anion and change the suffix of the anion to ic. So for instance, you see HNO3. So H indicates that it is an acid. You look at the anion. The anion is NO3. So you go look that up on the polyatomic list. That is nitrate. You're going to remove the 8 and replace it with ic. So it becomes nitric, and then add the word acid. There's a mnemonic that you can use to help you remember this, the 8 and the 8 part at least. So if you ate something icky, you might get the itis. Okay, so 8 goes with ic, ite goes with us. If you have ide, that goes with hydro and ic. Okay, so what does this look like on your naming flow chart? On your naming flow chart, this is the only part of the flow chart we have not done yet. The first question to ask yourself is there a metal in the compound? No. Is the first element hydrogen? If the first element is hydrogen, say yes, and that means you're looking at an acid. So if you have a hydrogen plus an element or plus an anion that ends in IDE, you're going to add hydro, you're going to have the root of your anion, and then you're going to replace the ide with ic. So hydro, root, ic acid. If you have H plus a polyatomic, if that polyatomic ends in 8, you're going to replace the 8 with an ic, and then add the word acid. If your polyatomic ends in ite, you're going to replace the ite with an us and add the word acid. Okay, let's practice a few of these. So let's start with HBr. HBr. So you say, is there a metal in the compound? No. They're going to the right on the flow chart. Is the first element a hydrogen? Yes, it is. So we have to take into consideration the name of the anion. This guy right here, Br, the anion is bromide, ends in IDE. So what we're going to do comes from bromine's ion. What we're going to do is we're going to, because this ends in ide, we're going to start off with writing the word hydro. Then we're going to have the root and then ic. Okay, so the ide we're going to replace with ic. So we're going to write hydro first. Then we're going to write our root, which is brom. And then we're going to replace the ide with ic, hydrobromic acid. Before we get to the next problem, I want to tell you a few exceptions that we have. Any compound that has sulfur in it, whether that's sulfide, sulfite, or sulfate, the root that we will use for the anion is sulfur, the entire word. So instead of like, if it was sulfide, we're not going to make it sulfic. Hydrosulfic, we make it hydrosulfuric acid. Okay? Any compound that has sulfur in it, the root is sulfur. Any compound that has phosphorus in it, so that means phosphide, phosphite, phosphate. The root is phosphor. That is your root. Those are your two exceptions that you need to know. Okay, so now let's get back to our examples. We did the first one when we said that was hydrobromic acid. Now we have H2SO3. Okay, this is an acid because it starts with hydrogen. So now we're going to look up to see what SO3 is. We looked that up on our polyatomic ion sheet, and we see it is sulfite. It ends in ite. So when you have something that ends in ite, we're going to replace the ite with us. So this is one of those exceptions. We're not just going to put sulfus there. We're going to use a different root for this one. It's going to be called sulfur and then an us. Sulfurous acid. Okay? Sulfurous acid. But we still have an OUS, which indicates an ite. Okay, now let's look at this one. Again, it's an acid. It starts with hydrogen. Let's go look up the anion. The polyatomic is sulfate. Sulfate ends in 8. We're going to replace the 8 with an ic. Our root is sulfur. And then we're going to put, instead of saying 8, we're going to put an ic there and add the word acid. Sulfuric acid. Okay, let's practice another one. We have HF. What is our anion here? Our anion here is fluoride, ends in ide. So we're going to add the name hydro. We're going to add the hydro, and then we're going to replace the ide with ic, and then add the word acid. So hydrofluoric acid. Replace the ide with ic, hydrofluoric acid. So if you see a hydro and an ic, that's because it came from an ide. Okay, now let's look at this guy. It is an acid because it starts with hydrogen. So let's go look at what the anion is. Look it up on the polyatomic sheet. This guy is carbonate. So what do? We replace the 8 with ic. So we get carbonic acid, or we pronounce this carbonic acid. Carbonic acid. Okay. Okay, so now that we've learned how to do our acids, what if we're given the name? Can we write the formula? To write the formula for an acid, we're just going to reverse engineer what we just did. We're always going to use hydrogen as the cation. We're treating these as ionic compounds. We're going to use hydrogen as the cation. And so our anion, we're going to get from the name of the acid. We're just going to reverse engineer it. And then once we figure out the name of the anion, we can figure out its formula, and then we can use our ionic rules to balance our charges or crisscross. So let's do one. This one says hypochlorous acid. Okay, this ends in OUS, so we have to figure out our anion. Our anion, if it was OUS before, if we went from OUS to ite, now we're going to go from, if we went from ite to OUS before, now we're going to go in the reverse direction. OUS, we're going to replace that with ITE. This is hypochlorite. We looked that up on our polyatomic sheet, and we see that that is ClO minus. Okay, to write our formula, we have to have a cation and an anion. Our cation is always H+. You put that together with ClO minus, you crisscross or you balance your charges, and you get HClO. Okay, next, you have chloric acid. Chloric acid. Okay, so you're going to take this chloric. Oh, it ends in ic. It doesn't have the word hydro. It just ends in ic. So this guy right here must have been an 8, chlorate. We're going to reverse engineer it. An ic by itself goes back to an 8. You get chlorate. Who is chlorate? Chlorate is ClO3 minus. To write the formula, we use H as our cation. This is our anion. We crisscross, balance our charges, whichever way, and you get this formula, HClO3. Okay, one more example, and then you will practice. Hydroiodic acid. Okay, this here has the word hydro, and it ends in ic, so it's hydroic. That means this guy must have ended in IDE. So our anion must have been, so our anion must have ended in IDE, so anion must have been iodide, which is from the iodine ion. Okay, so and that's I minus. So we're going to put that together with our hydrogen. And then we have an I minus. We crisscross or balance our charges, and we get HI. Okay, so why don't you pause the video right now to practice these 4 problems, and then we will talk about them. Okay, welcome back. Let's name these acids. HF. HF. Okay, so we need, this is an acid because it starts with hydrogen. So we need to figure out what the anion is. The anion is F minus, which is called fluoride. Because it ends in IDE, fluoride, we need to write the word hydro, and then we're going to replace the ide with ic, and then add the word acid. So this guy's name is hydrofluoric acid. We added hydro first, and we replaced the ide with ic, because this was fluoride. Okay, let's look at this one. So this is an acid. It starts with hydrogen. So we're going to look at the anion. The anion is CO3. When you look up CO3 on the polyatomic list, you see that that is carbonate. So we're going to replace the 8 with ic, because an 8 we're going to replace with ic, and it becomes carbonic acid. We already did this one as an example. So there it is. Now let's write the formulas for these acids. So this says acetic acid. It's ic, there's no hydro, so this must have been an acetate. When you look up acetate, you see that acetate is C2H3O2 minus. C2H3O2 minus. Let me do this on the next slide so you can actually see the work. Okay, see acetic acid, you replace the ic with 8, and it becomes acetate. We look up acetate, and acetate is this guy right here. This guy right here. So if you were to put the formula together, we're going to put an H+. We're going to combine it with this acetate. H have a -1. Crisscross, balance your charges, and you get this formula, HClO. C2H3O2. This is the acetate, that's the hydrogen. Okay, now let's look at hydrosulfuric acid. Now this has got the word hydro in it and it's got an ick. So the anion must have been sulfide because hydro plus ick means that your anion ended in ide. So this must have been sulfide. Sulfide is an S2 minus. Okay, so if we were to put this together, we have an H plus and we have an S minus 2. So if you crisscross those or you balance your charges, you get a formula of H2S. Okay, a couple other acids, just so you're aware of them. Same naming formulas work. Some of the important ones that we use a lot, hydrochloric acid, it is a strong acid. I think they're used in pools. Nitric acid, that one's very common that we use a lot. Sulfuric acid, which we've done, and phosphoric acid. This is the acid that's in your Coca-Cola. They all start with hydrogens. Some have 3 hydrogens, some have 2, some have 1. But these are just acids that we'll use a lot when we get to the acid and base unit. If you need any extra practice problems on any of these, whether it's acid naming, ionic naming, covalent naming, writing formulas, there is a lot of worksheets with answer keys provided in Schoology under extra practice. Thank you.